All right. Okay. This weekend, I will meet with the different groups for your project proposals. You'll come with me with your data, and we'll talk about it and just make sure you are set in the right direction. The purpose of these meetings is to make sure you guys are set up in a way that you can explore the data with curiosity, that the data is kind of big enough and set up in such a way that you can ask questions, turn to the data to try to seek out these answers and investigate. The meeting is not intended to be hostile, okay? But I will ask you questions about, have you thought about this? How are you going to address this concern or things like that? Um, so anyway, that's the hope of all of these different meetings and things like that. I have posted a couple examples here. I've posted two projects from past groups that earned A pluses on their reports, and and so I wanted to just kind of briefly go over these projects and just kind of point out a couple things. Um, One thing you'll notice is that both of these projects are super, super long. Okay. That is not the sign. I'm not going off of like how many pages you wrote as the sign for what makes a good project. Okay. But what I really like about both of these projects is that when the group noticed something odd or weird or interesting in either their data or their visualization or whatever it might be, they investigated it further. Okay, so that's so one is this Airbnb project, and then another is this Portuguese school academics thing. And neither group was like super expert on Chicago Airbnb or Portuguese school things. Okay, but but both groups went out of their way to kind of investigate and learn about the context of the data. Okay, so yeah, the Chicago Airbnb project that ended up being 57 pages. The Portuguese school one ended up being 99 pages. Okay, it doesn't have to be okay. Again, it doesn't have to be super long, but you'll find again they asked questions and they listed it out, and then a lot of the pages are just kind of like code output and graphs. Okay, but they talked about the different the data sets, but let me just kind of point out some of the things that I really liked, and I have a document with comments and things like that. So first they were kind of like looking at these Airbnb listings, and they looked at like, okay, what is the cost of an Airbnb listing, right? And so they were thinking like, okay, if we stay at an Airbnb, how much am I going to be paying? Maybe 150 a night, 200 a night, or something like that. And then, but when they created their kind of initial histogram, they saw like, oh, what? We got $50,000. All right, $50,000. And so they felt like, okay, that is really weird. Why is there the price so high? And so they looked at this, okay, and so they actually like looked up, they looked at the actual address, okay, on this thing in West Town or whatever, 747 Birdie Street, okay, and they looked at this, and it's a rental unit by this 22,528 per night. So this is indeed listed on the website like this, but they felt like this can't be a real listing. Like they felt like this is like some kind of fraudulent listing. Like no one's going to be paying $22,000 per night for a one-bedroom rental unit. Okay, and so they felt like, okay, there's something weird. This is not this. Even if it's listed on the website and the data reflects what it scraped off of the website, the group agreed like this, we should not include this in the data set because it doesn't make sense. Okay. Meanwhile, I think they found like another thing. They found another data set or another data point, and the data is still kind of like crazy, and it's like $2,000 per night or something. And they were like, "What is that?" So they look again. This is what I really liked is like they found things and they looked at the individual data point and they said, okay, what's going on here? Okay, and so they actually looked up the address on Airbnb and they found it and they said, oh, here is a mansion with 5 bedrooms or whatever, can fit 14 guests or something. And it's like, okay, I guess maybe somebody might have a big party and rent it out for $2,000 a night or something like that, right? And so they decided this one seems like a legitimate listing, and they included it in the data set and things like that. But I really liked that that they went through the data, kind of not necessarily line by line, but anytime something kind of set off their senses, like something's a little bit off, they didn't just leave it and keep trudging ahead, but they actually took the time to kind of investigate and things like that. Okay, and so and they did looked at these different listings here. Okay, as far as the Portuguese school data set, okay, they were just kind of wondering, and they asked a lot of questions. So in the Portuguese school grading system, students are graded on a scale of 0 to 20, okay, where 20 is the maximum possible grade, and I think passing is like, I forget what the cutoff is for passing. And then, and you have 3 quarters, kind of, 3, I guess, grading periods. And so you get, grade at the end of G1, a grade at the end of G2, a grade at the end of G3. You have these different demographic things. And they kind of just ask the question about like, all right, are any of these things associated and related to, different kind of scores? Okay. And so, they kind of go through this, and then they just said, all right, what if we look at, different kind of age groups, okay? And these are the different distributions. I think this is high school, and so, 15, 16, 17, 18, and then some older students. And then they kind of said, all right, what's the distribution of grades? And so they looked up, like, how would you convert from, say, this 20-point scale to like an A through F scale, which is kind of what we're accustomed to in the United States. And so they kind of colored these things accordingly. And, and so for certain things, there's not a huge amount of change, okay? But then you notice, like, okay, if you're looking at like the Portuguese grade scale and stuff like that, people age 19, there's kind of a higher proportion of D's and F's and things like that. And so, they notice these kinds of differences in the plots, and then they follow it up with a statistical test to see, okay, is the difference that we're seeing, is that statistically significant or not? Okay, and they kind of go through this, and they the reason why this report is so long is because they kind of go through each of these different variables, and they look at age, and then they look at sex, and they look at there were other variables related to social support, and what's their relationship with their family. Do they say I have a good relationship with my family, or things like that? And they kind of create corresponding plots, and along with the corresponding plots, they have different tests. Okay, one thing that this group ended up getting an A+, but I did tell them, one thing that they do need to work on is just adding a little bit more explanation going along with each kind of plot. They do add explanations for the plots kind of at the end, but you kind of have to wade through a lot to get there. But again, both of these projects reflect, in my opinion, a true curiosity with the data, and it's kind of this. We went out and we explored, we found, and we recorded what we found, and then we found something that seemed kind of interesting or unusual, and they further explored that. And so that's the hope, and this is why, for the data that you're working with, I want, ideally it's a data set that you're interested in. Because when you're naturally interested in something, you're naturally going to be inclined to have questions and have curiosity and want to explore those answers and things like that. So anyway, I'm looking forward to our meetings on Sunday. I think all but one group has submitted their kind of proposal questionnaire. And so I'm gonna read through the proposal questionnaires tonight and Saturday, and so just make sure you have those submitted. And then there's a couple groups where the link to the data doesn't work, and so I think I put a comment in the on Canvas or on Brew and Learn about. Just making sure the link works. If there's no comment on Canvas, then you're fine. Okay, but anyway, okay. Yes, question.
So if we did get a comment, is it okay to just put the link to the data comment itself?
Yeah, that's fine. Yeah, I just want to make sure I can see the data myself. Okay. All right. I was going to do just a little bit more, just kind of examples. If you have a particular data set, or if you have questions on like a certain technique that would be helpful, as you're exploring your data, and you're not quite sure, come talk to me in office hours. And if it seems like this is something that could benefit the class, I can make a lecture out of it as well. Here, this is. I think there's a group that's working with a similar but obviously different data set. But this one, I'm taking data from, there was like somebody scraped all of the different movies and TV shows that were available on Netflix. This is a few years ago. I think July 2022 is when they scraped it. And so you can see this is what the raw CSV looks like, okay? And, you have shows and movies. There's descriptions of the shows, when what the movie release year is, and then the rating, the runtime, and then there's like genres. And then they tried to find the matching like IMDb code, and then they also found things like the IMDb score and how many votes and things like that. And so, there's shows like I don't know. Let me check kind of, because again, it's like from 2022, so it's this really really big data set. But I think what are some examples of, I don't know, movies and shows? I don't know. So you have, I don't know, Just Say Yes, and The Race and things like that. Okay, anyway, just a bunch of things, and then they wanted to do some kind of analysis here, right? So, one kind of question they had was like, okay, let's look at the release year, and let's just see like when the movies were released. So as far as this goes, we can just So I think I put the script on Brew and Learn, and you can also download the titles.csv file. Okay, so we're just going to create a histogram using release year, and then add a few labels. And so this is kind of the plot of release year. And so what we see is, oh yeah, they have a lot of stuff from like the last 10 years. Okay, and then as you go farther and farther back, that you have fewer and fewer things, which makes sense, because as far as like shows and movies that people want to watch, more likely to want to watch something that was more recent. Okay, and like, as far as like old movies go, because as far as movies and TVs go, like they make a lot of movies and TVs every single year, and a lot of them are junk. and people are willing to watch not super great movies if it came out recently, because it might have like the popular actor of the current day, and then once it's over a decade old, then it's like, oh yeah, I'm not gonna watch that movie from 2005 starring, I don't know, whoever was popular in 2005. Okay, so that's so anyway, this reflects that. There are some classic movies that have withstood the age test of time. But if I say name 10 movies that came out in 1980, I think that'd be tough. Versus name 10 movies that came out in the last year. That's still kind of hard, but generally easier. Okay. Anyway, what I'm gonna do here is we have movies and shows, and so I said, okay, well, what if we split this between a plot? This is for all of the titles. Okay, so here I'm using Facet Grid. I think we covered Facet Grid, right? Yeah, we definitely we had Facet Grid as one of the things that you can do. So as far as we're going to do Facet Grid on the variable type, and so now I will have a plot for the movies that were released and shows that were released, and they both kind of follow a similar distribution here. If you don't like the vertical nature of it, okay, you can make it side by side. All right, and now we can see a greater difference as far as the heights go, and we can see there's a lot more kind of movies versus shows, and that also makes sense because you might have like 30 episodes to a show, but that only gets registered as one title. Okay. And we have that, and then looking at the distribution of movies, prior to 1980, there's not a ton, but there's definitely movies. Prior to 1980, there are very few shows that anybody wants to watch coming from before 1980. Okay, so I don't know what's a show from prior to 1980. I think you'd like Leave It to Beaver. I don't even think that's on Netflix or something, Okay, so anyway, we have that. And then if you want to kind of create a side-by-side thing, you can do that. Here I'm doing geom bar position equals dodge. And that will put the movies and the shows on the same plot, and then you can kind of see the height difference for each of these things. Okay. Here, we might have a curiosity and just say like, okay, there are hardly any shows prior to 1980 or even 1990 for that matter. And so maybe we just want to see like what shows these are. Okay, so as far as titles go, so here, this is not a plot. This is just trying to see what they are. So I'm saying I'm just curious what shows are on Netflix prior that are older than 1990. And so we have, so I said filter to show release years 1990 or less, and then tell me what these things are. So we have Fime came back. This is okay. So this is actually like a special case where there was like a documentary, and then they have the reference films. Okay, so you have Monty Python, Danger Mouse, Knight Rider, Wheel of Fortune, Thomas and Friends, Fireman Sam, High Risks, Seinfeld, and Saved by the Bell, as far as shows from prior to 1990, and those are the things there. Okay. One of the things that make this data set a little bit challenging to work with, okay, is this column called genre, right? And so you have these movies or TV shows that fall into multiple genre categories, okay? So you have things like documentaries, you have this is a movie that counts as both a drama movie and a crime movie, okay? This is another movie, but this one, the genres are drama, action, thriller, European, apparently that's a genre, okay? Fantasy, action, and comedy, things like that. This is like a fun trivia game. If it's like, oh, a famous movie, I don't know, a movie from 1989, rated PG, and it's a comedy, drama, romance. I don't know. What is that? Comedy, drama, romance? 1989. Do we know this? Steel Magnolias. Okay, would we have known that? I don't know. But you can kind of play this reverse trivia. Now I'm curious. Okay. So anyway, so you have this, but working with a column that consists of kind of multiple things like this, just makes it tough. So what we have to do is we want to kind of start to, we want to process this column. And basically, what I'm going to do is I'm going to create a new column called is drama. And if the genre column has the word genre in it, we're going to say, yes, it's a drama, or no, it's not. Okay. And then we'll have another column for comedy. Is it a comedy? Yes or no. Is it a crime movie? Yes or no. Okay. And so to do that, I'm going to use mutate. Okay. And I'm going to mutate a whole bunch of new columns. Okay. There's probably even more genres than this, but this is the ones that I've done. So I'm going to create a new column called is comedy, is drama, is animation. And to do this, I'm going to use the function string detect. And again, string detect, I think we talked about it in our last lecture. We're just going to search to see, does this word exist in that column? And so if we see the word comedy, it'll detect true or false. Does it detect the word drama? Does it detect the word animation, family, so on and so forth? And so I'm going to do this with some of the genres, and we're going to mutate all of these new columns. And we will call view, just to kind of, anytime you do mutate, it's always a good idea to view your results after the fact to just make sure it works. Okay, so we have, let's see. So I'm gonna, shoot. I want to view this. Okay, how do I do this? All right, so we'll see. Okay, Taxi Driver is a movie. It's drama and crime. And so we'll scroll over, and it looks like is drama comes back true, and then is crime comes back true, and everything else is false. And so that's what we want to see. Okay, and so we can kind of look at like this third row right here. It's true for drama, true for action, and that's it. And let's just go back and just see. And it was drama, action, thriller, European. So true for drama, true for action. I don't have thriller or European as columns of their own, but if we wanted to, we can do that. Okay. Oh, this is unrelated to anything, but I saw this and I thought it was funny. It's like Gen Z dplyr. This is a for real. This is a for real package that you can add, and if you want to install it, and it's basically just a translation of the verbs in the tidyverse into I guess into Gen Z speak. So you have filter, yeah. So you have Gen Z player. Okay, yeah. Filter is yeet, meaning remove rows that don't pass the vibe check. Select the verb is vibe check. Keep only columns that matter. Yeah, you have group by is squad up. Group the data into squads, ungroup and stuff. What's that?
The main character.
Yeah, pull is main character. Extract a column. Give it main character energy. Yeah. So. Yeah. Okay. Anyway. Right join is clout chase. Inner join is mutuals only. Okay. Anyway, I just thought it was funny. This is like it actually works. The documentation is the okay. Anyway, but you can do that. I probably prefer if you don't. Okay. So anyway, I've created new columns here, and so now we can do something like, okay, how many of these titles are comedies, or how many of these titles are dramas? Now you can call sum onto a column of trues and falses, and R will automatically convert falses to 0 and trues to 1s. And so if you do that, you'll get a sum of basically things that are true. And so you'll get a count of how many things show up as true under comedy and how many things show up as true under drama. And so we can do that, and we can get like how many movies are comedies and how many movies are dramas. And so looking at that, we have 2,325 comedy movies or shows, 2,968 drama movies and shows. Okay, now there are a bunch of these things, and I could do this. I can do summarize, comedy count, sum is comedy, drama count, sum is drama. I don't know, animation count is animation. I can do that. It's a little bit tedious, okay? So there is a function called across, and you give it a bunch of columns, and here we're going to say run summarize and sum across all of the columns that start with is, because that's when I mutated all of these columns, I had to do is comedy, is drama, is animation. Like this part, there's no shortcut for this. You have to kind of manually name all of the columns you're going to do. But here, now that I have them all named with is, I'm going to call summarize this, and we get the sums across all of the columns. So we have is comedy, is drama. The sums are 2325, 2968, 705, so on and so forth. And so we have all of these things. Okay. Okay. Here I can say group by type before we do this summarize. So I can say, okay, well, what about movies and what about shows? Can I split this up? Okay, so I'm calling group by, and then we can see, okay, we have this many comedy movies, we have this many comedy shows, we have this many drama movies, this many drama shows, and so on and so forth. Action movies and action shows, and so this, these kinds of numbers, and then you can, once you have this, you can create plots and stuff like that, right? So I can, once I have this, for example, maybe I want to pivot longer, and we'll do is comedy through is document. And I think that will do it. Okay. And then I'm going to call ggplot AES. Let's put X is going to be the name, and Y is going to be value, and then fill will be type, and we're going to do geom_bar. Oh, not bar, column, geom col. All right, so we have actions and drama things, and we get a split there. I don't know. Maybe I have to do position equals dodge. All right, so you get kind of a split. See how many things you have here, and so we see actually, you know, for most of these, there's more movies than shows. Okay, but some of the things, there's actually more shows than movies. So is sci-fi, there's more sci-fi shows than movies. Okay, family, there's almost an equal count there. But yeah, as far as comedies and dramas, there's a lot more comedy movies than there are comedy shows and stuff like that, right? So this is kind of a interesting finding there. Here, I thought one thing that could be interesting to kind of look at. Oh, I always forget. Let me give you. Have I given you any view quiz answers yet? No. Okay, let me look these up. Week 6 Friday. All right. First two answers are B and E. B for your first answer. Second answer is E. B and E. Okay. All right. So I was just curious if there's certain combinations of genres that occur kind of frequently, right? Like if you look at this, we have drama, crime. So that seems to be like a common combination. Okay. Here's crime, romance. I don't know, right? Like certain things, like maybe we would expect like romance and comedy to be a combination or something like that. You know, I don't know. So, some of these maybe not, you know, family and comedy, that makes sense. Animation and family would kind of make sense, but then I don't know. Are there like one of the genres is war. I don't know. Is there a war in comedy? Probably. I don't know. Maybe, but maybe not that many. What about crime in comedy? Yeah, maybe some, but I'm not sure. So anyway, I just thought like, okay, can we figure this out? So here I'm going to say, all right, let's pick all of the things where comedy is true. Okay. Filter the titles to where comedy is a true. So we know it's a comedy, and then we want to look at all of the other kind of genre combinations. So we're going to do start with is. We're going to sum them up. Okay, so there's a total of 2,325 comedies. Of those comedies, 958 are dramas. 388 animation, 443 family, action, horror, 74. You know, not too many comedy horrors, but I guess that is you know, it does exist. Historic comedies are not that common either. comedy shows or movies, but also historic or things like that. You know. Stuff like not not super common. So anyway, what I can do is I can kind of pivot these, okay? And what we'll have here is, so I'm going to pivot longer. So we're going to have just one column. And this is like all of these that are comedies and also dramas, animations, and things like that, okay? And I'm going to do the same thing, but we want, we're going to do this for all of the drama titles, okay? So of the drama ones, and so we should have matching numbers, okay? And so if we look at, of the comedies, 958 are dramas, and of the dramas, 958 are comedies. So we are getting alignment there. That's good, okay? Here, there's a lot of kind of drama things, and so, as far as the different numbers, there's not, none that are super small. Not a ton of drama animations, but they do exist, and stuff like that. So, we can do this with, what about animation? Okay, and so if we look at animation genre combinations, which ones show up very frequently, right? So, there, as far as animations go, there's only 705 to begin with, but we see there's a lot of kind of family and action things, not a lot of animated history or animated documentaries, okay, and stuff like that. So anyway, I'm creating these for the different genres, and we'll combine them. And so we're going to do, we'll take the comedies and we're going to left join them with the dramas, left join them with these different counts. And so now we have a plot showing all of these things here, okay? And then so now we can just say, like, all right, what if we we can create a plot with this. There's all kinds of stuff you can do once you have your table, okay? So I can say ggplot, and let's put, well, actually, what I'm going to have to do is I'm going to have to pivot this longer. Comedy count through family count. Okay. And let's just take a look at what that looks like. Okay, so I'm going to put this into ggplot. Let's put x on name, y is going to be value, and then we'll add s. Okay, so we have that. Animation, comedy, drama count, family count. Maybe we'll do fill. It's going to be the genre. And okay, and then maybe stacked. Stacked equals true, is it? I forget. Oh, position is fill? I forget. So I probably need to remove kind of the things that overlap, but you can kind of see some proportional differences as far as actions and things like that. So yeah, it's a little, this is because of the overlap here. I think we have to fix some of these things, but comedy. Anyway, just kind of exploratory analysis as far as dealing with different kinds of data. Okay, and so I think there might be one or two groups that have something similar. Okay, obviously I didn't choose one that's going to be exactly the same, but you might run into issues where you have a column where you have multiple things listed there, or perhaps it's a text column with different kinds of information in there, and you have to kind of extract out that stuff. And so with that, you'll use something like string detect. Okay, or if you have trouble, don't hesitate to ask me. I'm happy to kind of guide you as far as like establishing a new column and getting that information out. Okay, I'm looking forward to seeing the different kinds of projects. Some of the proposals do look really interesting. Some of the other proposals, I'll definitely want to guide and direct or perhaps redirect you. And again, during our meeting on Sunday, it's not intended to be a hostile thing. It is. I am trying to help you have a good data set that you can work with and explore thoroughly. Okay, we'll wrap things up here. Let me give you your last answer. Last answer is D. D as in dog. D as in dog. Okay, so we'll wrap things up there. Have a great weekend, and we'll see you on Monday.